Alright, number 41. The sequence below, in sequence there's two types, geometric and arithmetic. And remember, with geometric it's going to be multiplying, with arithmetic it's going to be adding. So 2, 8, 32, 128. How do you get to the next number? If you say you add 6, does that work for 8 to 32? I don't think so. So we're going to multiply by 4. 8 times 4 gives us 32. 32 times 4 gives us 128. So the pattern is multiplying by 4, so it is a geometric sequence. Alright, it says which formula can be used to determine the number of trees they will plant next year, and that's our next, if the number of trees planted this year now is known. So in other words, I should just be able to plug in these numbers to these equations and it should always work. So I'm looking, the only ones that have multiply are A and B and C. They all have multiply in there. D only has addition. So D's definitely not right, because D is an arithmetic. And C has two operations. It has multiply and add, but as we just proved up here, all you have to do is multiply. So I can cancel out C because it has two operations. Now A and B, it's between those two, and we know that it's multiplying by 4, so we know the answer choice is A. But let's just be devil's advocate. When do you think B would work? Well, what if we had, for instance, 80 was our first number, our next number was 20, our next number was 5, and then 1.25. So in that case, don't think you're dividing by 4, because geometric sequences are always using multiplication. So instead of saying divided by 4, we want to say that we're multiplying by the reciprocal of that. And what's the reciprocal of 4 over 1? 1 over 4. So same thing here, we're dividing by 4, which is the same as multiplying by 1/4. Same thing here, we're multiplying by 1/4. So if the number is getting smaller, it's reducing. It's always going to be a fraction. If it's getting bigger, it's going to be a number greater than 1. So answer choice is A, and we can always plug that in to check. So let's say if 8 is our next number, then that should be 4 times our now. So if I call that now, the next one is next. So if 8 is my next, then 2 should be my now. Well, 4 times 2 gives me 8, and I can keep doing that. That means that 8 will then become my now, so now I could plug in 4 times 8, and that should give me my next, which is 32, and that's true. And then 32 becomes my now, so now I plug it in. 4 times 32, that should equal my next number, which is 128. So always make sure that you plug it back in to check it, and that it makes sense all the way throughout. Alright, number 42. There were originally 4 trees in an orchard. Well, that's like my y-intercept. And each year the owner planted the same number of trees. Well, that's my slope, because that's a rate. In the 29th year there were 178 trees in the orchard. Which function t of n can be used to determine the number of trees in the orchard in any year n? Well, I know y equals mx plus b, where m is my slope, b is my y-intercept, and I also know that they're using t of n, so they're just using a little bit differently there. So what do I not know? Well, I know my y-intercept, so I can plug that in. It's plus 4. I don't know my slope, and they're using n instead of x, so it's going to be something here times n plus 4. Well, I can already look at my answer choices. B has subtract 4, D has subtract 4, so it's probably not going to be B or D. It's probably between A or C. How do I find slope? What's my slope formula? y2 minus y1 over x2 minus x1. So I need to know 2 ordered pairs. Do I have 2 ordered pairs? Well, I have my y-intercept, 4 trees. What year is this happening in? The 0 year. That's before you even started, so we'd say 0 at the beginning amount. So 0, comma 4 is my first ordered pair. And then I'm actually given another ordered pair here because it says in the, I'll erase that, it says in the 29th year, and remember n stands for the number of years, so that's our, in other words, our x. So 29, comma 178 trees, that's our y, so comma 178. So we have 2 ordered pairs. We just had to look for them a little bit. We have a y-intercept, and then we actually have another ordered pair. 29th year, it's 178 trees. So now I just label these x1, y1, x2, y2, and I just plug them into my formula. So 178 minus 4 over 29 minus 0. So it's 174 over 29. If I divide that out, I get 6. So 6 is my slope. So now that I have that, I just plug it in, and my equation is going to be C. Alright, so it definitely works. And just to let you know, I can plug in to prove it, and I'm going to prove why A doesn't work now. If I plugged in a 29 for n, and did 178 divided by 29 times 29 plus 4, I would get 178 plus 4, which is 182. Well, it says in 29 years it should be 178, so that's how I proved A wrong. But if I plug it in here and plug it in 29, 29 times 6 gives me 174, and then 174 plus 4 gives me 178. So C checks, and it also works for the other ordered pair for 0, 4. If I plugged in a 0 for n, 6 times 0 is 0, plus 4 is 4, so that would be 0, comma 4. So it works on both accounts, so C is our best choice.